Hi everyone, we're here with SJPO 2018 Q7. So we're given that a bug is on a circular turntable of radius r, but it's halfway between the center and the edge. Right? What does that mean? That means it's at the radius r/2, and that would imply that in order to keep it at a constant radius of r/2, right? If we want to keep the bug at a constant radial coordinate, right? Then we actually need to apply a centripetal force to keep it in motion at that radial coordinate, right? At a constant radial coordinate. So the radial coordinate as a function of time is constant. And remember that that implies, right? If you're not sure why this is the case, then please review the previous video on centripetal force. But that will imply that the force in the radial the force in the radial component must be minus m omega squared r, where r is the radius they're trying to keep it at, right? So in this case, what is the force? What is the force providing centripetal force? Right? In this case, the forces acting on the bug are just there are three forces acting on the bug, right? So if we look at it from the side view like this, right? If we look at it from the side view, then the bug is somewhere like this. Okay, so this is the origin, and the bug is at radius r/2, and the bug has three forces acting on it: gravitational force, normal contact force, and frictional force. Right? So friction, remember friction um friction will adjust its value to whatever it needs to be. So what does that mean in this context? It means that in this context, if you turn the turntable, the bug will actually want to move away from the origin, right? So the friction will need to be inward. So this is friction, F friction. So in this case, friction is pointing toward the origin, and friction is the one that is providing the necessary centripetal force to keep the bug at that constant radius. And moreover, right, we know that friction, right, is bounded by mu n, right? In this case, mu being 1/4, right? This is mu being 1/4. But we're given the fact that friction is just barely hanging on only, right? Meaning that since it's about to slip over here, it says that it's about to slip. That means in this case, friction is actually equals to mu n, right? Because it's about to slip, using the fact that it's about to slip. Okay? So with this, right, we can see that a few points. We can see that friction is equals to mu n since it's about to slip, and friction is the one that's providing the centripetal force. So equating the two, right? We actually get that mu n, right? Mu n is equals to m omega squared r, and r in this case is big R/2, right? In this case, n is mg, right? Big N is mg. So from here we can see that what's the final quantity I'm interested in? The final quantity I'm interested in is the acceleration of the bug. So the acceleration of the bug is omega squared r/2. Okay, and in this case, acceleration is simply mu times g. In this case, mu is 1/4. So the answer is 1/4g. So the answer is E. Okay? So I'll see you in the next question.